Okay, so we're going to be exploring series and parallel circuits using TinkerCad. When you're logged in, go ahead and click New Circuit. Once that loads, we're going to start off with a 3-volt battery over here. So go ahead and bring one to the bottom. We're actually going to zoom in a little bit so it's larger on the screen, easier to see. And with the battery selected, we're going to go ahead and rotate 1, 2, 3 times so that the positive is to the right, the negative is to the left. That will make it easier for us to wire it. And you'll see in a moment why we're doing that. We're going to do the same battery, but we're going to put another one over here on the other side. Let's rotate it also. There we go. Okay, awesome. Now let's bring in some LEDs. Now this one, I'm going to stack 1, 2, 3 LEDs on top of each other. For this one, we're going to put them in a series. We're going to put them next to each other. 1, 2, and 3. Okay, and let's start with our series circuit. So with the electricity flow, it's going to leave the negative side of the battery here, and it's going to flow to the negative leg or the cathode of the first LED. The electricity will then travel through the LED, out the anode, the positive, and from the positive to the negative, flow through that LED, light it up from positive to negative, flow through that one, and then it'll go from the positive terminal to the positive of the battery. Okay, so in this case, the LEDs share the same electricity here, the same flow. They have to share it between the 3 of them. In a parallel, they don't share it in the same way. They actually each get the full amount from the battery. So in this case, it's going to go through here, through the light bulb, and back over here. But for the second one, it's actually going to go through from the negative to the negative, right? It's going to travel through here, flow through, and then flow back out. And for the last one, same thing. The electricity is going to travel through all of these, right? So it'll travel through here, up and out, up and out, up and out, okay? All right, so let's test it out. Let's start our simulation. And interesting. Look at that. We have, in a parallel circuit, there's way too much power for these 3. But in a series, there wasn't enough power. So, well, that's because these 3 are sharing the 3 volts. So they're each really only getting about 1 volt, right? In this one, not. In this one, they're each getting the full amount. So we have to change this up a little bit. We got to make some modifications. So let me show you a couple things. Okay, let's stop our simulation here. All right, so since this was too much, remember we talked a little bit about resistors. I'm going to delete this negative leg here, and I'm going to add a resistor. Okay, now remember, a resistor helps to control the flow of energy through a circuit. So it resists energy. So the higher the resistance, the less energy flows through a circuit. Okay, so by adding resistance, we can lower the amount of energy that's going through there. That way we don't get that little a warning message on the LEDs. When you click the resistor, you see there's different colors here, and those colors actually change based on the resistance amount. And luckily for us, we don't have to be electricians today. We don't have to memorize these codes, but because the computer is going to do it for us. But we're going to change the resistance here from kilo ohms, from 1,000 ohms, to actually just ohms. Okay, and if I have it just at 1 ohm and I do a start simulation, you'll see that it's still too much. But let's change 1 to 10. Let's add a 0 there. And all of a sudden, that's already enough resistance to make them optimal. Now, I want to find the point at which these LEDs can be the brightest they can without getting the warning message. So I'm going to lower the resistance here. Let's try 5. No, 5, I still get it. Let's try 6. Oh, there it is. Okay, so 6 is the minimum amount where my LEDs will be the brightest, but without getting the warning sign. Okay, so that's how you use resistors. One of your tasks is going to be to figure out how to create a parallel circuit just like this with 5 LEDs using a 9-volt battery. So replacing this with a 9 volt, we're going to rotate this around also, and I want the positive to be on the other side, so I'm going to flip it by mirroring it, and there you go. Okay, and you need to add 2 more light bulbs there. And then I want you to figure out what the value of the resistor would be in this setup with 5 light bulbs, because right now, as you can see, is way too much. So you're going to add 2 more light bulbs to the circuit, and then you're going to change the resistor value until you find the perfect amount so that you do not get a warning message, but it's still the brightest it can be. All right. Your second part is going to be to take this setup. Remember, we don't have enough here to light these light bulbs right now, so we're actually also going to add a 9 volt battery over here. Let's go ahead and rotate it and flip it. Okay, and add it right here. Add the negative to the negative. Let's run the simulation, and it's still way too much now, right? Because you got these in series. Okay, so now I want you to add 2 more light bulbs and figure out, is that enough to keep the light bulbs from going out? Okay, so I want 5 here. Finish it up. Let me see what that looks like with 5 light bulbs. Remember, they share, so the more light bulbs, the more LEDs you add, the less voltage each gets. Whereas with a parallel circuit, having a resistor will help to lower the voltage. So you have those 2 assignments. Go ahead and give it a shot. Once you're done, show your teacher or take a screenshot of what you did. Good luck.